Our next topic in Unit 3 is called Systems of Equations. And systems of equations is a very complex topic that we're going to learn about, but we're going to be using some of the same information that we've already used in 8th grade. There are 3 methods to solve a system. There's graphing, which is what we're going to talk about in this video. There's substitution, which will be in the next video. And the last one is elimination, and that'll be another video. So just look at our definition here. It says a system of equations is 2 or more equations using the same variables. So up until this point, we've seen one equation with 2 variables in terms of maybe like slope-intercept form, y equals mx plus b. But a lot of times when we've been solving for variables, we've only seen one variable, right? So like solve this equation for x, or solve for z or a, or whatever variable they might use. Where systems is different is we have 2 or more equations using the same variable. So we're gonna be dealing with 2 equations here in 8th grade, and most of the time the variables that we're going to use are x and y. And the reason we use x and y is because the goal here is to find the one ordered pair. Remember, that is x comma y, that works or is a solution in both equations. Okay, so we're gonna hear this word a lot, solution. Okay, so find the one ordered pair that works in both of our equations. Okay, so we have 3 possible solutions. Remember, solution is just the answer. Okay, the first one we would call one solution. So when we have one solution, when we graph these equations, and when our graphing is going to be the same, we're going to put the equations in slope-intercept form, and we're going to graph them just like we normally graph slope-intercept equations, begin with B and move with M. We're going to have 2 lines though, and the 2 lines, how they look on the graph is going to tell us what the solution is. Okay, so if we have one solution, that means that we're going to have intersecting lines. So we're going to have 2 lines and they intersect, or they cross at a point. That point where they cross is our solution, right? That's our one ordered pair that works in both equations. So we would have, if it crosses in the first quadrant, then we'd have something that has a positive x number and a positive y number. Okay, so that's one of our possible solutions. Another solution that we could have, we call no solution. So in terms of a graph, if we have no solution, and we just said the definition of the solution is where the graphs cross, if we have no solution, that means that our lines will never cross. Therefore, they're called parallel lines. So there is no ordered pair that works in both equations, okay, for no solution. So we're going to see how that relates to the slope and the y-intercept in just a minute. The last solution we could have, we call infinitely many solutions. So there's an infinite number of ordered pairs that will work in both equations. So how will these lines look? Well, they will be the same lines, or the same line. So we'll graph one line, then we go to graph the other line, and it lies right on top of the first line we graph. So they would have the same slope and the same y-intercept. Okay, so infinitely many solutions. We have an infinite number of ordered pairs that will work for x and y. No solution, there is no ordered pair that will work. One solution, we have one ordered pair that will work in both equations. So down here, just remember how to graph. So just make sure both equations are in slope-intercept form. That's y equals mx plus b. We already know that. We've spent a lot of time on that. And I told you we're going to use slope-intercept form a lot. And here's where it's going to come back into play. Remember, m is our slope, b is our y-intercept. We always begin with b. That's plotting the y-intercept on the y-axis. Then we move with m. Remember, we use slope, or rise over run, to plot more points. And then we draw a line through our points. So remember, 5 points is a good number to go for when we're making our lines. Okay, so let's take a look at this page here. We have some bullet points that we want to look at and see if we can fill in these blanks. So what these bullet points are going to do is they're going to ask us some questions, or there's some statements that will kind of help us figure out how to identify the solution of the system when both equations are written in slope-intercept form. So the first bullet says, in a system of equations, if the slope is the same in both equations and the y-intercept is the same, there are blank solutions. The lines are blank. So let's see if we can write an equation here. It says the slope is the same. So remember, we're going to have two equations, and they're both in slope-intercept form, y equals mx plus b. Slope is the same. That means m is the same number, right? So let's just say, for example, it's 3. And the y-intercept is the same. Well, y-intercept is b, so that means the b has to be the same. So let's just say y-intercept is 2. Okay, so if we look here, we have the same exact equation. Okay, so if we have the same exact equation, then those lines, when we graph them, are going to be right on top of each other. So we would say that there are infinitely many solutions, because the solution is where the lines cross, and if they cross continuously through the same line, then there are infinitely many solutions. The lines are the same, or the same lines. They're right on top of each other. So if we graph this, we'd graph one, and when we go to graph the other one, it would lie right on top of the first line. Next one says, in a system of equations, if the slope is the same, but the y-intercept is different, there is blank solution, the lines are blank. Okay, so once again, tells us the slope is the same, so let's use 3 again as our slope. Y equals 3x. But the difference here says the y-intercepts are different. So let's say one is 4 and one is 5. Okay, so we have different numbers here. Okay, so if we look here, if we were going to graph those, we would say begin with B and move with M, right? So if we just said, make our little graph here, plus 4, so we'd start there and we go up 3, right 1, it would look something like that. Well, if I graph this one, my first point's going to be 1 higher, and I'm still going to go up 3, right 1, so look what's going to happen to my lines. They're going to be parallel, right? So the lines are parallel, and that tells us that they're never going to cross, so there is no solution. Okay, so if the slope is the same, but the y-intercept is different, there are no solutions, and the lines are parallel. The last one says, in a system of equations, if the slope is different and the y-intercept is the same or different, there are blank solutions, the lines are blank. So the key here is the slope is different. So if we notice up here, slope was the same, slope was the same, slope is different. So anytime the slope is different, there's going to be one solution, because that means that those lines have different rates of change. So they will increase at different rates, meaning that at some point those lines will cross. So these lines are intersecting lines. Okay, so if we wanted to write a couple equations, we could say maybe y equals 2x plus 3 and y equals x plus 5. So we know that at some point those lines will cross, right? It would look something like, I don't know if this is exactly the slopes that they will have, but they will have a cross, they will have an intersection, and at that place where they intersect, that is our solution, right? That would be a point on the graph, and we could tell what that ordered pair is, and that ordered pair will be our solution. So the last thing we're going to do with graphing is we're going to look at some examples, and we're going to actually graph a couple to see if we can figure out what the solution is for these systems. Okay, so the first two we'll look at, we have y equals 2x minus 3, and we have y equals negative 3x plus 2. So we'll look at those two equations first, and we're going to graph them, and we'll see if we can tell what our solution is. So the beauty about number one is both equations are already in slope-intercept form, so all we have to do is begin with B and move with M. So let's graph one equation at a time. So we have y equals 2x minus 3. So I know I'm going to begin with B, so 1, 2, and 3. I put my first point there. Now my slope is 2, so I go up 1, 2, right 1, 1, 2, 1, and go back here. To my y-intercept, I go down 2, left 1, down 2, left 1. And I can take my ruler, and I give myself my line. Okay, so there is my first equation. Now my second equation says y equals negative 3x plus 2. So begin with B, for my first point at positive 2, and now my slope is negative 3, so I'm going to go down 1, 2, 3, and right 1. 1, 2, 3, 1. I can stop there because if you notice, I already have a point where these two lines will cross, and where they cross is my solution. So what we'll do is we'll circle the intersection. That's going to tell us what the answer is. And now all we have to do is write down the ordered pair. So we would say that the solution is 1, negative 1. 1, negative 1. Write it as an ordered pair, put a box around it, and we're done. We found our solution. All right, on number 2, if we notice, both these equations are not in slope-intercept form. They're in standard form. So for us to be able to graph them, we're going to have to put them in slope-intercept form. Okay, so let's do a little work with these equations. We know that we're trying to make it say y equals mx plus b. So if I look here, I'm going to have to add 3x to both sides. Okay, so I get my equation as 3y equals 3x plus 4. I'll divide both sides by 3 to get my variable as just y. So my first equation is going to be y equals x plus 4/3. Y equals x plus 4/3. All right, so I can put a box around this because I know that I'm going to be graphing that in just a minute. My second equation, I know all I have to do is add x to both sides. And my equation states y equals x plus 3. So there's my second equation. All right, so I'm going to graph these. So my first equation, I kind of have a messy y-intercept, but that's okay. 4/3, I can think that is 1 1/3. So I can put my point somewhere around there. And my slope is 1. Okay, so I go up here and I go up 1, right 1, up 1, right 1, and I have my line. So I could even go down 1 and left 1. Okay, so now I take my line, or my ruler, make my straight line. Now my second equation is y equals x plus 3. So plus 3 is right there, but I have the same slope. So up 1, right 1, up 1, right 1, and what do you notice about my lines is that they are going to be parallel. Okay, and the reason we know that is because of what we did back here. We said that if the slope is the same, but the y-intercept is different, there is no solution. The lines are parallel. Okay, so we had the same slope. Our slope was 1, right, or 1, because a 1 is before the x. Okay, so we would say that the answer is no solution. That's all we have to write, no solution, because the lines do not cross. All right, number 3. Once again, we have equations that are not in slope-intercept form, so we're going to put them in slope-intercept form. We'll work them down here. Let's call this equation number 1, this one number 2. So number 1, we have negative 2x minus y equals 1. So we will add 2x to both sides. Negative y equals 2x plus 1. And we have to divide everything by negative 1 because we don't want negative y, we want positive y. So there's our first equation. So we could say that this is y equals negative 2x minus 1. And that gives us our equation in slope-intercept form. So now we can graph that in just a second. Equation number 2 is negative 6x equals 3y plus 3. Here I'm going to go ahead and subtract 3 because I want to get my y on its own side of the equation. So I have negative 6x minus 3 equals 3y. Divide everything by 3, and I get negative 2x minus 1 equals y. And I could rewrite that with y on the left side. Y equals negative 2x minus 1. And if we notice here, what are we going to have? Y equals negative 2x minus 1. The same exact equation. So when we go to graph this, put our first point at negative 1, down to right 1, down to right 1, because our slope is negative 2. Also, we could go up to left 1. And we have our graph here, our line. And then what happens when we go to graph the other one? Negative 1, down to right 1, down to right 1. We get the same line. Okay, so over here we saw that when we have the same slope, same y-intercept, we have infinitely many solutions because our lines are the same. And they cross at an infinite number of points because these lines go on and on and on forever in both directions. Okay, so all we have to write is infinitely many solutions, and that is our answer. So far we've seen an example of one solution, the lines crossed. No solution, the lines were parallel. Infinitely many solutions, the lines were the same line. So the last one we're going to look at is a word problem, and we're going to have to take the words that they gave us and write equations, then graph them. Okay, so it says find two numbers that have a sum of 7 and a difference of 1. Okay, so sum means addition, difference means subtraction. So two numbers we could say x and y. So x plus y, a sum of 7, x minus y, a difference of 1. So to graph those, we got to put them in slope-intercept form. So the first one, we just need to subtract x from both sides, and we get y equals negative x plus 7. Over here, we have to do a little bit more work to it. Subtract x, and we get negative y equals negative x plus 1. But we don't want negative y, so we divide everything by negative 1, and we get y equals x minus 1. So those are our two equations that we're going to graph. Okay, so look at our first equation. Y equals negative x plus 7. Put our first point at 1, 2, 3, 4, 5, 6, 7. And we go down 1, right 1, down 1, right 1, or up 1, left 1, up 1, left 1. And we can put a line through our points. Second equation, y equals x minus 1. So minus 1 is where I begin. Up 1, right 1, up 1, right 1. I'm going to keep going until I make contact with my other line. And we have done that. So we draw our line there, and we can circle our point of intersection. So our answer is 4, 3. So 4, 3. And we can check that, right? So two numbers that have a sum of 7. So 4 plus 3 equals 7. Difference of 1. 4 minus 3 equals 1. So this is systems of equations with graphing. Remember, if our lines intersect, that means that the slopes were different. Y-intercept could be the same or different. That gave us intersecting lines. That gave us one solution. If our slopes are the same and the y-intercepts are different, we're going to have parallel lines, which means no solution. If our slopes are the same and our y-intercepts are the same, it's going to be the same line. We have infinitely many solutions.